should be streaming again. I have a bit of a sniffle, so I might not last too long. We'll see how it goes and such. What do we have on the screen? Yeah, there's the chat thing. That's about all you need. We will save it for later. Oops, wrong one. I want to get rid of this and put it somewhere up there, I guess. I suppose. We'll draw. Just go through some of the arguments that have already been argued by me, but not counter-argued by the them. And it just seems universal that everybody who disagrees with me, won't do it in some sort of fair manner where they take the actual argument and explain how there is evidence in the record demonstrating it to be incorrect or inaccurate or impossible or something like that. And instead they just insult and slander and pretend they have counter-argued when they haven't come anywhere close to forming any kind of appropriate counter-theoretical position. Alright, so the first argument, number one argument, alright, is the simple gravity thing. Okay, that it's basically pretty clear that the force, because it says it right in the theory, 9.8 meters, okay, per second. Alright, and it doesn't matter whether you say per second, per second, per second, per second, per second. It just matters that you say per second. That the force is acquired in units of time. Alright, and the fact is when you're falling, those units of time, okay, are, in the case of falling, the units of time are proportioned 1 and 3 here. These are the same units of time. This amount of time is the same amount of this amount of time. So this distance happens in the same amount of time that this whole distance happens. And the truth is that the fact is that when you're falling in gravity, all you fall are 2 units of time, okay, with 2 different amounts of distance. So I could make the time 1 millisecond, I could make the time 10 seconds, I can make it any amount, and no matter what amount I'm counting in, I can always apportion it into the fact that it's going to have this ratio. It'll always have this ratio. No matter how far I drop it in space or from any distance, I can always guarantee that it'll do this 1, 3. It's 5, 7. It keeps going, but it'll do this 1, 3 thing. So gravity is acquired, in allotments of as time passes and you're free falling. Now, if you interrupt the free fall by hitting you with air molecules or actually letting you bounce off of something, then you'll lose whatever velocity you have. You'll lose this relationship and you'll start essentially over, reacquiring velocity depending on how much you lost to that process. So clearly it's not something that would be called linear. It's not something, gravity, that has some relation to linear distance. It clearly just has to do with how much time you're falling. And so when they create other equations like mgh, indicating how high you are, indicates how much energy you'll have. My simple argument is this cannot possibly be interesting, correct, okay, because we already know it's 2 units of time. It's not 4 units of distance. 4 units of distance won't tell you how much gravity you free fell in. 2 units of time tell you. And the fact is when you hit the ground, okay, another well-established fact, is that you only weigh twice as much. So your weight is 2, okay, the time is 2 units of time, and there's another 2 in there. 2, yeah, what is it? 2 units of time, 2 units of, 2 units of velocity, obviously. And so this one sort of, for all of us, the intuition part would be twice the velocity is only twice the velocity. It isn't 4 times the energy. So they really believe that, 1 unit of velocity, whoops, that's a 2. 1 unit of velocity equals 2 units of energy. So I'd say again, wrong. That's just a bad idea. I shouldn't have done that. And then they have a work equation where they say work, which is another way of saying energy, right? Who wouldn't call work using energy? Is force times distance. Obviously, again, just way off. We know it's the force times how much time the force has to be collected in the case of gravity, or in the case of going up against gravity. Okay, you're going to end up having to, you only need twice the velocity, proven fact, to go 4 times the height. Okay, so to restore your height, you just have to do the same thing you did before, which is 2x the velocity will get you to 4 times the height. So again, it's just about how 9.8 meters per second is you're gaining whatever this is, okay, this velocity, that you're gaining it, okay, and you're gaining the same amount. You only get 9.8 meters here, and you only get 9.8 meters here. That's why you only hit the ground at 19.6 or whatever it is. Okay, you only hit the ground at 19.6 meters of velocity. Say if we use 2 real seconds and allowed something to fall. That's all. Okay, it's just twice the velocity of the velocity here. So clearly distance gives you an incorrect answer. I mean, it doesn't give you the force times distance, the number that they're expecting, or that they're 1/2 mv squared. I mean, they're essentially saying this equals 1/2 mv squared. Obviously the number would be much larger. Their prediction would be 4 units of distance, and so this would be 40, and it doesn't land at 40. It doesn't have twice the velocity. It only, 4 times the velocity. It only has twice the velocity. So this is clearly, this is just wrong. It's time gives you the right answer. So I've been over this. You can also see it in just ground friction. So when you roll objects on the ground, they do the same thing. If I give it twice the velocity, and this one has 1 velocity, okay, the 1 velocity goes this far, and the twice the velocity goes 4 times the 4x the distance. But did it do 4x the work? What you're doing by allowing, now see, if I throw the objects off the edge of a table, okay, I have a table and I just throw the objects off the edge of a table, twice the velocity will just give me twice the distance. I can't do anything else. So all I get is 2x the distance. So obviously this formula doesn't even work in that context. In this context, what you're actually doing is stopping the object. Here you're not stopping the object from forwardly moving. So you're not going to get the same results. And but in this case, when you're rolling something, you're basically excreting all of the energy out of the object and making it come to a stop. And the fact that they stop at this strange disproportion, okay, one of them 4 times the distance of the other, even though it's only 2x the velocity. But you can see it in the sense that here's the halfway point. Here's where this goes 1/2 the speed. That's at here, it's going the same speed as this. So here, it duplicates what's happening here. And you see exactly the same thing happens. This does equal this. And this, okay, you just have to argue, is also equal because it's the halfway point. So the fact is that the friction, anyway, so the friction, okay, for this whole path is the same. This path here is the same for this path here, and the 2x the velocity, the other portion of the velocity gave you this whole distance here. because the friction was less. And you could really understand how, oh yeah, of course it's less, because you could understand if you were rolling across a scale, you could understand the faster you roll across the scale. If I just put a scale in here somewhere, I would weigh less and less depending on how fast I was going. So if I measured at my peak velocity, I would weigh less. Then I'll measure here, or I'll measure here, or I'll measure here. I'll weigh a lot more here because I'm going a lot slower across the scale. So per foot, you can understand you're not giving away the same energy because you're not placing the same pressure on the road. So it makes perfectly good sense to understand that this is 1 unit and this is 1 unit, and those make up your 2 units of velocity. And this is just, it's not a trick. It just takes a little bit of understanding to recognize that 4 times the distance is, you know, it could be a trap for somebody who doesn't think very well or think very completely. That, you know, you'll be tricked by the fact that, okay, it looks like 4 times the work, but it really wasn't 4 times the work because it wasn't 4 times the friction wasn't being extracted at the rate of 4 times as much. It was only twice as much. This whole section weighed what this section weighed, okay, in terms of the amount of pressure being placed on the ground. And this completely, perfectly equals this. And the same thing happens when you shoot things up into gravity. The speed thing, it's all the same thing going down, same thing going back up. You go back up, it gets, you know, you're going slow here, you're going faster here, you're going faster here, and then you go slow for that last little bit. And it's the same relationship. So that's the argument against. Now I can go through all the other little pieces of the argument, but this is why there is an argument, is because Leibniz and later some others didn't pay much attention to the simple dynamic of the fact that, and the fact that Newton had already explained that doesn't this is how it works, in a sense explained it. I guess he didn't explain it this carefully. But anyway, so the whole reason why this 1/2 mv squared exists as a theory, competing against Newton's theory, where Newton got a bunch of right answers, and people said somehow Newton's physics was broken, even though he wasn't getting any wrong answers. Okay, so there's nothing broken in understanding. It's just about momentum. Momentum is just weight. Okay, and weight is created by velocity. And the key ingredient is time, how long you're applying a certain amount of weight or a pressure. Will tell you how much total energy you have. And so Newton formed the equation, essentially, all right, where he stated that force, or energy, right, it's another pseudonym for energy, okay, just equals your momentum over any unit of time you choose. So if you want to know the total force, you just do the total time, okay, and frankly then time is nothing because it's on both sides essentially, and you can just get rid of and just recognize that energy equals momentum. He basically said you can exchange a hunk of force for a hunk of momentum. So if you want to have twice the momentum, you apply twice the force. And obviously you'd usually do that through increasing the velocity. So twice the velocity, twice the force, twice the momentum, twice the weight. Not 4 times anything. So anyway, so this little trick is it. That's why there was the initiation of the theory. Now lots of people pointed out that this doesn't match their understanding of how the world works. So I guess we'll go through some of those counter arguments that were made, and some of them are just simple, lever type arguments, simple devices that we know their reliable functionality would no longer be sensible in the universe. They wouldn't fit. The physics wouldn't match the outcomes and the idea of conservation of the momentum. So this is another, it sort of challenges kind of clearly, if you think about it, this new formulation challenges the idea of conservation, of Descartes' most specifically, assertion that the universe already has its energy in it, and the energy is just moving from object to object to object to object through this process of momentum exchanges. Bowling balls hit the pins collect the energy that the bowling ball had, and dissipate it into other objects they hit, the air and the walls and whatever is in the way. And everything just dissipates energy, and the dissipation gets smaller and smaller. Objects are starting to move, more and more invisible objects move, and so we call it heat, or we call it energy loss, but it really hasn't been lost. It's just been dissipated into the environment, into smaller and smaller objects that we can't see, is the basic idea. So the argument was made that simple devices, I'm going to have to sneeze, I think. Anyway, like a lever, okay, that do a simple thing. They just basically convert a weight. Okay, so I can put a 2 mass here, I can put a 1 mass out here, and they're doing a simple, I guess I should make it smaller. Alright, and they're just basically doing a simple conversion. This now weighs what this weighs because it's 2 units of distance, so it moves twice the amount of time, the amount of distance in the same unit of time. So in the same unit of time, this one moves twice as fast, it weighs half as much, momentum is conserved, force is conserved, energy is conserved. This works, okay, with MV as the understanding of what energy is. It doesn't obviously work with 1/2 mv squared. It doesn't work because I end up having 4x, okay, no, 2x, alright. I end up having, even though they weigh the same, and the oscillator can oscillate with the same energy, presumably on both sides. According to 1/2 mv squared, I would have twice as much energy on this side, twice the momentum, essentially, as I would have on this side. And I can't have twice the energy because that would be free energy. I just put in 1 unit of energy and I get 2 back. Now, I've sort of made the point that you can know this from a scale argument that springs, for example, also. It can't take 4 times the energy to compress a spring twice as much, and twice the compression gives you twice the amount of velocity. And so this is sort of a known fact. And so if I put objects on a scale, I understand that if I put 1 object on the scale, that's 1 unit of energy that would require. And if I put a second object on the scale, that's only 2 units of energy. It's only 2 units of work. How could that? When we know the scale has to go twice as far, so it compresses twice as much, so there's another 2. It can't possibly have 4 times the energy. Okay, it can't have 4 times the energy because it's only 2 units of weight, and I can't create 2 units of weight and then get 4 units of weight out. I can't. This isn't fit with reality. So I've also pointed out that you could make arguments about gears, okay, and they do the same thing as the lever's doing. Essentially, you're saying that if I have a gear that's twice the circumference of the other gear, and I put objects, I can put weights on the 2 different surfaces. I could put a 2 mass on the small gear is going to be the same as a 1/2 mass or 1 mass on the bigger gear. I'm going to again get twice the velocity here that I'm going to get here. I can turn some object or throw some object, and it's can't come out the way they predict. It has to be twice the velocity. It's fixed objects. And then you can also just use a hydraulic argument that if you drop something on cylinders, that were tied together, 2 cylinders, and you had 1 cylinder on the other side, okay, that these 2 would move, okay, sharing the energy, the pressure, the weight, and that this one would have to double the velocity. So this one would do the same thing the lever does. These would move 1 unit of distance, and this one would move 2 units of distance in the same amount of time. And you would basically be able to convert a 10-ton train going 5 miles an hour into a 5-ton train going 10 miles an hour. And according to this theory, this train has twice the energy. So we don't have any evidence of any of this. So their theory is that it takes 4 times the fuel, okay, to go 2x the velocity. That's their theory. So 60 miles an hour takes 4 times more fuel than 30 miles an hour. That's the implication of the theory, and we don't have any evidence of that. We don't have any evidence that a 5-ton train going 10 miles an hour is twice as powerful as a 10-ton train going 5 miles an hour. That the momentums are the same and somehow the energies are uneven. And we certainly don't have any evidence that you could, add, they've done this experiment, you take a 5-ton train, okay, so to speak, and you drop another 5 on it, okay, and you create a 10, and the 10 leaves the experiment with what you would predict, which is half the velocity. So you do your experiment, you end up with a 10 here, okay. You get 10 bigger. So you just converted as efficiently as possible a 5-ton train going 10 miles an hour, okay, into a 10-ton train going 5 miles an hour. And it comes out exactly that way. That experiment's been done over and over again. Very little reason to doubt the outcome of the experiment. So you have exactly 1/2 the velocity, okay, a little tiny bit less, because you can't do it perfectly. So you lose a little tiny bit, just the tiniest of fractions. 0.99% of the energy is conserved, the momentum. And their argument to you would be is that you lost half the energy in the process. And they'll say that there was sound and vibrations and bent metal and all kinds of things that actually don't happen in the experiment. And that even if they did, you'd be stuck with the question, well, how can you bend things or make sounds or move things, make pins move without hitting them with a bowling ball? How can you not use something's momentum to create sound or sparks or vibrations or any of that stuff? You have to use something's momentum to do it. You can't do it without using energy, using something's, as Newton would say, at quantity of motion. You have to use something's quantity of motion. Some quantity of motion that exists in the universe has to be applied for the sound to be made, or the spark to be made, or the bent metal to take place. It has to absorb energy. It has to dissipate energy that was going in one way, and it has to dissipate it. And that dissipation has to be made out of real energy. It can't be just, you can't commit the thought crime of saying, I'll just imagine that it made all this happen without using any momentum. So you can't really conserve 99% of the momentum and then claim you lost 50%. And that's what their claim is. That's what this equation dictates, is that the perfectly efficient experiment that conserved the momentum lost half the energy. I mean, on its face, it's nonsensical. And the fact that they have zero physical evidence, they really can't produce a credible physical experiment demonstrating what they claim to be true, that it takes 4 times the energy to double the compression of a spring, when we know it only takes twice the weight, and I can produce twice the weight by only doing twice the work. It only takes twice the work to produce twice the weight. Undeniable fact, and critically important fact. And I mean, there should be some point where just everybody goes, oh, how is that possible? How could this argument even take place? Why don't we just shut up and all recognize that, wow, we made a terrible mistake, we got to fix that, because this is silly and stupid. Yeah, that's a dumb argument. How the hell can you conserve the momentum and knock pins down? How can your bowling ball still be going, okay, theoretically, with the same momentum, and yet you knocked a whole bunch of pins down? That can't happen. Yeah, that's probably enough for that subject. So that's the first argument against. Now, like I say, you can go through all the history. So I guess that's some part of this argument against kinetic energy. It's the part that struck my eye first, was the fact that the originator of it, Leibniz, overtly stated he didn't like Descartes' physics because there was no role for God to play. Yeah, Descartes was basically explaining that God initiates the universe and then walks away. And Leibniz didn't like that as a as a description of the Lord, that the Lord wouldn't walk away from the experiment, and he would want to be participating, and so he didn't like that part. He didn't like Newton's physics, called both of them too atheist, and so this is the mind that generated, proposed this argument without any evidence. Again, he didn't have any evidence. It took it took 4 horses to move twice the weight. He didn't have any physical experimental evidence saying that this was true, and all he had was this observation that when something rolls on a surface, that goes 4 times the distance, and that in gravity it has this optical illusion that the 1 velocity only does this, and the 2 velocity does this much bigger thing, 4 times the amount of show. And the point is, though, is if you're a physicist, go is different than show. It seems like, looks like, those can be big mistakes. And this is a big mistake. So anyway, Leibniz proposed it. The Newtonians did point out that, look, levers are free energy devices now. So if I believe Leibniz, I can make free energy. I can make a perpetual motion machine with levers and gears and hydraulics and little systems. I could create little machines that could go on forever and ever and ever, because I can just keep converting heavy things into light things. I can keep moving energy from a heavy thing, like Descartes would argue. The energy keeps moving. You can move the energy from every object can hit something bigger than it, or it can hit something smaller than it. And I can transfer the energy. Every time I transfer it to smaller things, I end up making free energy. Every time I transfer it to bigger things, I lose preposterous amounts of energy. So that simple argument was made, and Leibniz was defeated for that reason in that subject, and he lost credibility in other subjects, including who invented calculus, blah blah blah. It's not like Leibniz was a terrible scientist. He said a lot of things that are quite quotable and good, but he said a lot of things that were really quite stupid, and some of them absolutely wacky, like soliton and monad, in terms of believing that inanimate matter had a soul and all kinds of wacky crap. So anyway, and then the fact is that Leibniz died. Nobody showed up at the funeral. Obviously, Newton was buried as God, as a physics god. So Newton clearly won the argument, and then about 20 years after Newton's death, this was resurrected again as a fad, by a woman who happened to be tutored, by an old Leibnizian, one that was still around arguing for this mv squared crap. And he even sued her for plagiarism, because when she wrote, she basically verbatim was arguing his modified theory of Leibnizian physics. And so it's clear that, this is a bit of a bias when you're tutored, and she didn't have anything other than tutors. She didn't go to college. In basic mechanics by a guy who is basically an old cult member of the mv squared religion, and it was only mv squared back then, not 1/2. And so it didn't get right answers. Got grossly exaggerated, twice as much. It was already that much broken. It's broken, and with the half in it, it's even more broken without the half. In terms of getting the actual getting close to some kind of realistic understanding of energy in the universe. And so to reinforce the occult theory, there was a guy in the Netherlands who did some clay experiments, and I guess I should just point out why that evidence wasn't what all that people thought it to be, okay, or were tricked by it. So they could show, that twice the velocity gave you 4 times the height. They could show that twice the velocity gave you 4 times the distance. And if you didn't really understand that it's 9.8 meters per second, you didn't really think about it, people could be tricked by that. And then they had a third trick, essentially. And so all you need is a few tricks. You pull a rabbit out of your hat, you pull a few doves out of your sleeve, you pop some flowers out of your hand, and there might be a point where the person thinks the magic guy is really the magic guy. He's not just tricking you, that he's actually got superpowers. There's some point where you could be fooled. I mean, certainly a primitive tribe, you could understand, could be fooled by a modern magician quite easily. The power of his card tricks, even. The sleight of hand. And I would argue that this is all just kind of a sleight of hand that nature produced. It created a circumstance like the platypus. It walks like a duck. It has a bill like a duck, has feet like a duck. It does certain things like a duck, but it's not nothing. It's not a duck. Okay. It's just fooling you. It's not nature trying to fool you. It's just happens that it turns out that way, that it created 2 coincidences. You could say the jaguar versus the leopard. I mean, they look like, they should be related, but they're really distant relations. There's probably lots of other examples of something that looks like something, but it's a completely different thing. Okay. Alright, so which argument was I going to do? Oh yeah, so the clay. So in the middle of we're talking about like 1740-ish, so this is in the resurrection mood of the 1/2 mv squared. Okay, so I mean it's the mv squared, and it was called the living force. Vis viva had kind of a horrible name. So it was just mv squared versus just the plain mass and velocity, momentum, weight. This is all you really need. And they put this square on here just to make it messy, frankly. Alright, so you do an experiment, you just drop round things into clay, and then you drop one of them to get to twice the velocity. You have to go 4 times higher. Okay, so it's only, make it the same size. It's only twice the velocity, right? So the 4 times the height is only 2x the velocity. It still doesn't really, so I just put 4 marks on here so you get the idea. It's 4 times the height. But it's only twice the velocity. And then you drop it into a substance. So this is like rolling. And you're saying, well, how far does it go? How much clay does it displace? And so the idea is what's the volume of the dent it makes? And the fact is the one going twice as fast will make a volume difference of 4x. So here you have another example where 2, it's only 2 units of time, 2 units of velocity. It's only going to weigh, when it hits the surface, this is only going to weigh twice as much weight. Okay? So somehow twice as much weight is going to push into the clay 4 times as much, okay, in terms of its displacement. Now, you could analyze this and say, well, did you try the experiment with square things? Okay. And the fact is you could expect that you might get a different result. That if you did it with pointy things, you might get a different result. So that's what wasn't shown. So one experiment that produces the 4x was shown. The experiments that don't produce the 4x weren't. And really the physics part is just understanding that a round object Okay, that doesn't go all the way in. See, we're just talking about denting clay. The object doesn't actually go more than halfway through. So it's just denting the surface. It's just enough energy to dent the clay, not to go into the clay. So you could understand that a round object kind of has more than one surface. Okay, at the bottom it is very much a square, okay, a flat surface. And at the side it's very much, it's very much a sloped surface. And you have everything in between, right? So you have every ramp, okay, in between happening. So it's a wedge, kind of obviously. It's an inclined plane all over the place. Lots of inclined planes here. And what the real point is that if you did actually have to push the clay, say you have a little particles of clay in here, and the idea is you're going to get rid of them and replace them with this thing. This thing's going to move these things out of its way and take their place in space. And what it has to do to the clay when it's flat? Well, when it's flat, it has to push the clay in, and then it has to push the clay sideways. Where if it hits clay that's moving out, and on these surfaces it's not having to push it all the way down and over, it's able to take the shorter path, this hypotenuse. So instead of doing this motion, this longer distance, it just has to do this distance, and at this location it just has to do this distance, and at this location it just has to do this, and obviously at the side it just has to do this tiny bit of moving. So you have to do a lot more work the more flat surface you're applying. And so obviously in this case the amount of flat surface, okay, is this one with twice the velocity has an advantage because it will go deeper because it's twice the velocity, and it will be using more of this surface than it'll be doing of this surface. And this one, because it doesn't go as deep, will be hitting with this flat surface more than it'll be hitting with this. So this will be 60-40 say going this way, and this one's 40-60, going down. Well, I mean down part, you could go 60-40. Okay, going down. So it's doing more down work. This one's doing more sideways work. Therefore, this one has an easier ride, until they get equalized, until they go deep enough into the clay. If they went all the way down here into the clay, then the advantages don't exist anymore because they're both have the same amount of liability, because one doesn't take advantage of the fact that this is a sloped surface, and the deeper you go, the more you take advantage of the slope until you get to this halfway point where you've both done the same amount of work. You both use the slope the same amount. You both use the flat surface the same amount. You both use the sideways surface the same amount. So when you're just denting the clay, there's a disproportion. When you penetrate the clay, there's no disproportion. But again, if they had used square blocks or some other shape, a cylinder even, the advantage wouldn't exist, and the outcome probably, would have been consistent with what seems rational, that twice the velocity, twice the weight, twice the compression, not 4 times. Twice the amount of work can be done, not 4 times the work. And so there is the Mythbusters experiment that kind of debunks this, where they do the 2-to-1 velocity, and I should have wrote that the other way. Oh, you can't see it anyway. They did the 2-to-1 velocity experiment, so twice the velocity versus 1 velocity, and smashed clay, and the clay came out perfectly consistent with Descartesian physics. That is, yes, 1-to-2 relationship, twice the velocity, twice the energy, twice the compression, twice the weight. But this is, you can say, okay, back in the 1700s, you could see, okay, maybe they just weren't sophisticated enough to do the analysis. Now, I think they really were, frankly. The physicists should have figured out this round object into clay thing. They should have figured out that friction, linear friction, isn't the same. It's not the same energy going into the ground no matter what speed you go. The faster you go across a scale, the less the scale deflects. Obviously, the less energy going into the ground. And the stupid little shooting things into gravity argument, clearly it's about time. It's about how long it travels in the gravity against the gravity. Four times the distance, it's only twice the time, okay, to do the 4 times the distance. And 9.8 meters per second kind of gives it away. It's about time. It's not about distance. I can do, a simpler Newtonian kind of argument. This is how Newton understood how the universe worked, and this is what they're disputing, that somehow it isn't as simple and as easy to understand as that. It's, Newton didn't say gravity is like sand and you're collecting it in a bucket, but he could have. Certainly could have. It would have been consistent with what he understood. So Newton understood that gravity produces an effect like light, like photons. And the fact is that the faster you go through the gravity, the less photons that'll hit you, the less force you'll be affected by. Now, the argument is it's really the gravity is a push and it's coming from the outside. And you're just really saying that you have an imbalance of force. You have less coming out of here than you have coming out of here, and therefore the longer you're in the differential, the more you're going to get bent. But the simple argument is it's completely time dependent. The faster I go through the gravity, the less I'm bent. And the slower I go, the more likely it is I'm going to just crash into the object. I'm going to be overwhelmed by the amount of gravity I'm getting exposed to, because I'm going to get skin cancer, because I'm going to spend a lot of time being affected by the differential. There's a differential. I'm going to be in it a long time. I'm going to be affected a lot. If I'm in the differential a little bit of time, I'm going to be affected very little. That's Newtonian physics. That's what got right answers. That's what's got Newton buried as a god, is understanding gravity as a time-dependent force. Time. It's how much time gravity can work on you will decide how much energy you collect from it. Alright. We'll take a break and then maybe we'll do some double slit arguments or some gravitational lensing arguments or some other physics arguments. But that's why the mv square thing exists. It's just, okay, there were a few little optically confusing experiments, you could argue, and the physics apparently wasn't sophisticated enough to protect itself against falling for what it looks like rather than what it is like. So they ruined physics, basically, because they couldn't tell the difference between looks like and is like. So I don't know what these stupid little handy things are. Silent lamb. Well, that's really just not very interesting. So I think I'll just delete it because it's really stupid. Oh, God. Human beings. Part of me just says, maybe I'll just leave this as this subject. No point in competing subjects. So that's the subject. I mean, it's a fundamental part of physics. So I can add a few more details. All right, so there's those 3 experiments. Clay, dropping around things in clay, rolling things on surfaces, absorbing their energy, and measuring how much energy they have based on how far they travel, rather than what you can understand, which is how much did they heat the ground. And that twice the velocity is just going to get you twice the heating. It's not going to get you 4 times the heating. It's not going to rattle the ground 4 times as much. The 4 times the distance just means that there's an unevenness in how the force will be distributed. When the velocity is high, it loses less per foot than when it's low. And the same argument could be made with what happens if you want to get into space and you want to do as little work as possible. You try to go into space as fast as possible. Try to get to the highest velocity you can as quickly as possible to basically negate having to fight the force. 9.8 meters per second. You want to reduce how many of those 9.8 meters you are affected by, then you just reduce how much time it takes you to get from one place to another, point A to point B. The faster you go, the more efficient your fuel is, essentially, because you will evade the force that you're trying to overcome. So rocket engines get hugely more efficient the further you attempt to go, the less you pay per mile in fuel costs. So the longer you're in gravity per foot, the more you're going to pay for it. And the less time you spend in a foot of space, the less work you'll have to do. I mean, logic is perfectly sensible and reasonable and undeniable. I suppose we could do the spaceship argument is sort of related to how you think things work in space. Is another pretty good argument against any notion that this mv squared stuff has anything to do with reality. So I guess I'll do that. Since there are no reasonable participation by the audience at this time, the 11 people, yeah, the limited audience I'm given by the forces that be, that I am exposed to, that are exposed to the fact that there are arguments that can be made that they really can't counter with anything called evidence or reasoning. There's no way to defeat this argument because you will not be able to find any evidence that it takes 4 times the fuel to go twice as fast. It doesn't exist anywhere in the researchable, accessible human space. Alright, so another simple argument could have been made in Newtonian's day, because Newton knew what a spaceship was in theory. He knew that an asteroid, you could say, was a spaceship. So the simple argument would be is you have a spaceship, or it could be just an asteroid, and all we're going to say is it's moving in a direction, okay? It has a velocity, and then we're going to use thrust to turn it. And you can make lots of arguments about, by 1/2 mv squared, you have to recognize that small things going fast matters. So in this case, I could throw 1,000 atoms out this side of my ship, okay, going just 1 mile per hour. Or I could throw 1 atom out this side. So it could be an asteroid, and let's say there was a little explosion inside the asteroid, a little bit of water or something something happened. Something was building up, there was a little bit of pressure, pimple, whatever you want to call it, and it pops, and just 1 atom flies out at 1,000 miles an hour. Now, their theory is that this is 1,000 times more energy. So this is 1,000 times more energy here than here. Okay, so we're not stuck with just twice. This is 1,000 times more energy, because I'm squaring the 1,000. Okay, here I'm just squaring a 1. 1,000 times more energy. I mean, it's a bold statement that somehow this can do 1,000 times more work. So this is 1,000 times more joules. So it's 1,000 joules more. Times joules, 1,000 times the wattage, okay, because a watt is a joule. Horsepower, whatever you want to convert it into, this is 1,000 times more energy, okay. And so the argument would be, if you believe in equal and opposite reactions, I mean, to produce this, I have to have the opposite reaction, in the sense that now that I've released this, I would argue that the real effect is you release something that was giving you balance. So you had a balanced pressure inside your system, equal amount of weight, and you've removed one weight, and therefore the balance is now uneven. So so you're going to go this way because there's still a bunch of stuff inside of you going this way. You gave away that way, you still have stuff going this way, and depending on how much you gave away is exactly the weight you'll have going in the other direction, pushing in the other direction. So obviously, by their physics, okay, this spaceship has to radically turn. I mean, not a little bit. I mean, it's a huge amount of ground their engine the wrong way. Huge amount of turning force by throwing that out that way. I gave away a huge amount of balance. I got a huge weight in this direction. Now Newton would tell you, no, this is the same mv. This is the same weight. Okay, if I put this on the lever, okay, I can put 1,000 things, 1 unit of distance on the lever, and then I could put one thing, 1,000 units of distance on the lever, and they will balance. They'll equal the same thing. It's the same amount of energy. This equals this. This is not 1,000 times more, and it's not 1,000 times more thrust. So the spaceship continues to just go dead straight, because what it did here, the 1,000 atoms going 1 mile an hour, same thing as the 1 atom going 1,000. Same ability to do work, same pressure, same weight, same momentum. So I can't possibly turn the ship. So how can you have a theory that basically says this is real energy in the universe? The universe has 1,000 times more energy going that way than it has going that way. That's what they're saying. There's no balance. There's no Newton's third law. There's no energy conservation. It's clearly not a correct theory. It's clearly not how the universe works. The physical universe under space, okay, works. That's why NASA says we use Newtonian mechanics. They say they use Newtonian mechanics because they're basically saying we don't use Leibnizian mechanics. We don't use 1/2 mv squared. Yeah. So there is the more complete argument. Let's see. Oh, we have a comment. Okay, so let's see if we got anything here worth paying any attention to. Some kind of foreign gibberish name. Let's see. Hello, Gary, from the Russian-speaking Ephelis community. Well, I'm really not interested. This is a physics video, but whatever. Thank you for your for the foundation of Ephelism. So, yes, I don't. Okay, so yes, you decide to write it in spite of the fact that I've attempted to separate the two channels. They're completely separate channels, and that I make a distinct effort to try to tell people to stay on the fucking subject, and it's sort of important. Both channels have an important thing to say, and you're just muddying water, and that's just not very, you can say, oh, I like you, Gary, but I'm going to shit on your head, Thanks, but no thanks. It's okay. I mean, all right, fine. I'm glad you're enthusiastic and you want to fight for truth, justice, and the American way and all that crap, even though you're Russian. Yeah, great. Okay. Fight for the cause. But you don't do it here. This isn't the right place. It's the wrong cause. This is the physics cause. I'd argue the two are very connected, frankly, from my perspective. Getting the truth about the dark facts of our reality as human beings, the fact that it is a bug planet, that we really haven't evolved nearly enough to give ourselves credit to be anything better than just evil bugs, and that the whole thing needs raid. That argument, okay, is supported by this physics in the sense that the physics is unyielding. It is a deterministic universe made of a mechanical system. It's just a pot boiling. We're one of the little bubbles boiling, and we're torturing things to be a little bubble in the boiling water. And torturing things for something stupid is really dumb. And it's as dumb as falling for 4 times the distance. Yeah, it's just as dumb as falling for that. So yeah, there was nothing in the Brozoverse, the Brozozoic Yeah, nothing from the Brozozoic era of reasoning people. You know, the primitives, the dinosaurs, the physics dinosaurs. You know, in the last 2 days. So Brozo apparently has some secret problem that he can't talk about. I don't know that, so he can't be bothered, and all of the other players apparently are incapable of conversation. Piro is kind of desperate, you know, kind of wants to do something, but he doesn't know what to do, you know. So I think he wants the support of like-minded morons to commiserate with and just insult me in some kind of environment where they can just talk about my distorted or perverted psychology because I didn't fall for it's 4 times the distance, because I didn't fall for that. You know, I didn't fall for the little it seems like crap that, you know, I deserve to be insulted. Because he could make a counter argument to all the arguments I just made in this video, right? I mean, these are all point by point. You could just show how that isn't true. It isn't what happens. There's no experimental. You could just do that, and you know they don't. They don't show how it's 4 times the weight. You drop it from 4 times the height, it weighs 4 times as much. You know, because it doesn't, and that's a fact. And they can't show it weighing 4 times as much because it doesn't. Simple truth. So, but yes, there needs to be a, you know, interaction here. You know, they're just this form of interaction where they don't play the argument and don't respond to the argument. It's not good enough. I mean, obviously, I can't counter-argue their counter-argument because they won't make their counter-argument. All they'll do is lie about what I said and then argue straw man. You know. So they won't show where I made a mistake in any of the reasoning I did here, or any of the statements I made about the people involved. They won't show how those are lies or incorrect. Mistakes. They won't show them to be mistakes. I mean, that's all they could be. I mean, frankly, I don't lie. You know, but you just can't buy the argument. You can't solicit it from anybody. You know, I mean, I guess I wouldn't mind paying Piro. I mean, how much do I have to pay Piro to actually play the first half hour of this video, whatever it is, lengthwise? So it was an hour now. Yeah. But even the first half hour would be enough. You know, and actually respond to it. You know, explain how anything I said was wrong. But they won't do it. You know, simple truth. They won't pay attention to the subject, the physics argument. They won't argue the physics. They'll just argue my personality, or you know, somehow that I'm aberrant in some sort of unacceptable way, when I'd argue that whatever defects I have in personality are in fact not defects. It's the way people should be, honest. You know, try it sometime. You'll like it. It's very liberating. So, I guess a little 2-minute warning, you people. There's 14 of you. If you really can't compose any kind of comment at all, you could say something like, gee, you know, there really should be evidence. For them to be so confident and arrogant, they really should have some evidence defending their theory. I mean, they've had 350 years to produce it. I mean, what's the big hang-up? You know, they can't do this 4 times the fuel thing? I mean, there's lots of ways they could, you know, prove that if it was true, so why don't they get to proving it? I mean, the very fact that all you people don't require evidence, they don't have to show you anything, they just tell you, we found the Higgs boson, we did this, we did that, we measured the weight of a frog, we did this, we did, they tell you they did something, we did it, we found gravitational waves. They don't really show you any of the evidence. They don't show you the real story. I mean, even like LIGO, they keep talking about, we have a mile-long track of, 2-mile-long track of tunnel, the longest, evacuated tube on Earth, blah, 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 blah. And then they don't tell you that, yeah, we bounced the light back and forth 800 times. So that's 1,600 impacts with a mirror. So after 1,600 impacts with a mirror, we can measure the how fat is a proton. We can measure how the distance across from a proton's trunk to its anus. We can measure that distance with after we bang the photon into a mirror 1,600 times. That's what we can do. And you believe this shit. Why? Why are you so sure they are right? I mean, why are you so confident that these storytellers are doing anything but just telling you stories? Why? Alright, so Tim says, thanks for the summary of the arguments. I think my favorite argument is the dropping of the 5 mass on the 5 mass truck to get the 10 mass truck going half. Has anyone done this but Lewin? No, everybody's done this one. I mean, they do this one with ticker tape. Okay, they tie a little piece of ticker tape and they run it through a thing. So this one's been done so many times. So they use little carts, they use air track, they use all kinds of things, and now they use timing gates. But I mean, this experiment, there's got to be 100 versions at least, good versions, on the internet, I think. And it's just that it's always, the title isn't 10-ton versus 5-ton train, so you can't search really easy, but there's a ton of videos, and it always comes out a little bit, so the Lewin experiment is more, the one where the 3/4 mass, where they double the mass, and you're doing the opposite. You're banging the light thing going fast into the heavy thing, so it's an inverse. You're not creating the heavier thing. Let's see how to say that better. Yeah, I can't think of a way to say it better. You can't do it Newton's cradle, right? You can't do a Newton's cradle conversion. So you can't do it through banging the thing into it. You have to add the weight in some graceful way. You can't bang it into the 5-ton train can't bang into the 10-ton train, right? We know that's not going to work. So you have to do it by adding the weight to the 5-ton train. So anyway, every time they add the weight to the 5-ton train, okay, so they add 5 tons to the 5-ton train. Every time you add the weight rather than collide to cause the added weight, it comes out perfect 2-to-1. Okay, the velocity is exactly half the velocity. I'm just saying that the experiments come out really so close. You're saying like if the number's 49 going in, it's 48 going out. I mean, it's just really, really close. Alright, so anyway, it's pretty crazy they don't have evidence for going 4 times the fuel, for using 4 times the fuel. Yes. That's a simple thing, right? You're just saying in all the joule experiments, right? Collecting the heat, all these experiments they've done, they haven't done this simple experiment of showing it taking 4 times the fuel to go twice as fast. I mean, that's not asking much. That's not asking physics to go, to spend billions and billions of dollars. That's not like flying to Venus or something, right? I mean, that's not a big ask. What would I search for to find those experiments? Well, they're the conservation of momentum. And you might even put ticker tape in. Do a Google search with the term ticker tape, because a lot of them were with the tape, running a piece of tape on the cart, and then it has a little, it puts little space dots on the tape. It burns the tape, and the tape records the distances. It's basically a frame rate experiment. There's a really good one by, that this, South African universities did, so I can think of a few offhand. But it's conservation of momentum and carts. I don't know what added words you could use. But I'm saying every single one of them, where they drop the mass, they let the cart go, they just drop the mass on. Every single one is really just so close. There's just, like I said, 49, 48. Momentum, perfect momentum conservation, almost perfect. So little loss, and yet they claim half the energy was lost. So there's absolutely no momentum lost, but half the energy was lost. I mean, how could that make any sense to anybody reasonable? I didn't use any momentum, but I lost half the energy. All right. What is the name of your aphorism channel? Yeah. Well, it depends on what the debate is in the form of. I mean, it has to be, again, the same argument. But it's in Mendham. INMENDHAM. Or you can go to donotgod.com. I'm more actively protesting Google there, so I have half the videos are on the website and half the videos are on YouTube. See, there's certain, I shouldn't, I'm not going to make the comparison because I'm not going to make the arguments. But I'm just saying, some arguments are just undefeatable. And, people just won't play with them. I mean, I guess you could argue the 9.8 meters per second is just an undefeatable argument. Why are you measuring energy and distance when the force is telling you overtly, gravitational energy, is telling you it's a per second force. I mean, it's right in its title. I am a per second force. I am not a distance. I'm not a per foot force. Why the fuck are they measuring distance, right? It doesn't make any sense. So you could argue that the imposing of life argument is clearly, if you don't have something's consent, you're an evil imposer. How dare you tell some other creature it needs to be alive because you want it to be? How dare you invest its welfare in your judgment? Where did you get that authority? And that's an argument just can't be defeated. You are unethical scum. You baby makers are unethical scum. You really have no right to play with something else's welfare, and that's what you're doing. You're playing with it like it's a toy, like it's your gun. It's my gun. I can do whatever I want. I don't care where the bullets go. Fuck the victims. Alright, 2-minute warning. Physics arguments, please. Physics statements. Something on the subject of physics, please. Okay, there we go. Tim might save the day. I think it's interesting that if we don't have gravity on Earth, so... there's no place you can go where there's no gravity. I was trying to think, the moon has no atmosphere, but it just still has gravity, 1/6. The work equals force equals distance wouldn't make any sense because distance would just keep increasing without additional work. Yes, and also it would just be, like in the case of throwing things off a table, okay, you could stop the action. You can't use up the work though, right? Traveling through the atmosphere will, over time, finally degrade the velocity. So I guess if you let them fall long enough, then the distances will end up being distorted again because you allowed the atmosphere to do the same thing gravity does, which is disproportionately take the energy. But the atmosphere works the opposite though, right? The atmosphere, the faster you're going, the more trouble it causes. So actually you won't end up with results that match their theory. So if you let them, you shoot them off a table and let them fall for a very long time, they'll end up 2 to 1, maybe even worse. In terms of the fact that the faster object will be paying more than the slower object for in terms of air resistance. So yeah, it won't work. Okay, I'm just saying that their formula doesn't work. It only works in special circumstances, but it doesn't work in non-gravity. Obviously, you're not extracting the energy, so yeah, the things go forever. So twice the speed is only twice the distance. No matter where I measure it, I'm always going to find out that the thing going twice as fast has only gone twice as far. It hasn't gone 4 times as far. So yeah, it's completely gravity dependent, but I'm just saying it's their complete misunderstanding of friction. They think friction is some independent force that acts on things, when clearly friction is just bowling pins, and the bowling ball is the thing you want to not be in the friction, right? The bowling ball is the thing with the energy. The pins are going to take it. It's the same thing that's happening with friction. Friction is just you giving your bowling ball energy away to the little tiny pins. I mean, it's so obvious to me. I mean, it's just I just don't understand how you can't get this as a viable counter argument or counter theory, that all you can do is give it away. When I give away, if I give somebody $10, I don't need a counter force to make me $10 poorer. I'm $10 poorer automatically. The act of giving the thing giving the bowling pin my kicking energy already took my kicking energy. I already gave it away. I don't need a friction to take it. It's already gone. And that gets to the whole idea of the pressurized vessel, and the idea is that it's pressurized in all directions. When you're at equilibrium, you have just as much stuff going this way as that way inside of you. Just as much going this way as that way. You're at equilibrium. And if you let something go that way, you have to go this way, because now you've lost your equilibrium. Now you have more stuff hitting this wall. This side of me is getting hit by more stuff. If I give away spit, if I spit in that direction, I've given away a piece of my equilibrium. I've let stuff go that was going that way, and now I have to go this way because I'm not equal anymore. I don't have the same amount of stuff going this way as that way because I gave away stuff going that way. I mean, to me, that's a pretty logical argument. There's no equal and opposite reaction. There's the action itself does the job. Letting something go that way finishes the story. I don't have it anymore. Nothing else has to show up to make me go that way. Nothing has to show up and say, give me the $10. No, I already lost the $10. I don't have to give it to you because I already lost it. And such. Okay. So what we need is like 4 Tims, even though 4 Tims would probably just irritate me in some horrible way. you need a little more action in the comment section. But 12 viewers just ain't enough. You gotta do a little better. Probably a year from now, it'll still be 12. You know, just YouTube. I mean, they identified the objects just keep on moving. I don't know what that means in that context. Obviously, the difference between the two experiments is one experiment, when you're rolling on the ground, you are extracting its energy. The other experiment in space, you're not extracting its energy, so you can't measure its energy actually, because you're not extracting it. But they kept the work formula. Well, they kept all of them. But obviously, anything to do with distance and gravity would be a mistake. Now, distance not involving gravity could make sense. There can be correlations between how far you're going to go and how much of your force you've given away if you give it away to non-gravitational friction. So if they could create non-gravitational friction, like air resistance, the formula might actually work. So in air resistance, okay, there's a good likelihood that if you allow things to, you shoot them in air and keep them from falling in the gravity, air track for example, or some other mechanism, that distance will be equal, because that air resistance is going to be it's not a gravitationally dependent force. It's not gravity making the friction. It's not affecting how much friction there is. Gravity isn't pushing you into the surface of the air. So the number of air molecules you hit won't change based on how fast you're going. So if you're going very fast, you're going to hit a lot of air molecules. You're going very slow, you're going to, you're going to hit the same, you know what I mean? The number you hit isn't going to be affected by time. It's going to be affected by distance. So the formula does work in the right circumstances, but they don't do those experiments. So we don't have any other experiment. We can't show the other experiments because they don't do the experiments. And as Professor Lewin kind of shows, when they do now and then push the experiment envelope, they cheat. I mean, I think the spaceship thrust argument is pretty decisive. I mean, I've always liked it. It was actually brought up by a troll who was mocking me by saying, "What do you think? It's the same thing shooting a dime at 1,000 miles an hour and 2 liters of Coke out the other side? Do you think they're the same thing?" Yeah, yeah, I do. Obviously, they won't have the same impact because velocity matters to our skin. So he thinks because the bullet would go do a lot of damage and the 2 liters of Coke wouldn't do any damage because of the slower velocity. Because the bullet's really long, so to speak, and the velocity has been reduced to make the bullet much heavier. Yeah, I mean, obviously our skin is velocity affected. It's more affected by velocity than disproportionately. So the higher the velocity, the more it yields. The lower the velocity, the less it yields. Really easy. Oh dear, you're bringing up kooks. Let's see, change of subject. Well, I really don't want to do that. Let's see, Demystifying Science podcast has had on some people who promote push gravity models. The Hilster doesn't push a rational model. Okay, he has accepted particle force, but it's still, he says there's no charge. He says it's arbitrary. It's made up. It doesn't matter. I mean, it's the most elemental function in the universe is charge, for fuck's sake, and he discounts having to explain its existence. I mean, you know, especially when it creates magnetism and everything, electricity and everything. Frankly, it's just an idiotic theory. And then he has this whole expanding Earth crap, and you know, they don't think, they think the universe is infinitely fractalized or something. That, you know, there's infinitely, you know, you have some other. They believe in a whatever G2 particle that goes the speed of light squared. You know, there's a G2 particle. It's, you know, yeah, it's just all wacky shit. So frankly, not interested. I might go find the podcast you said. Is it a real podcast or is it a video cast? I don't I don't know if I find podcasts all that interesting. But they're not going to demystify anything. I mean, D. Hilster doesn't even make Lissasian type arguments. He doesn't even put it into any kind of rational context because, like I said, he's making this. He doesn't, you know, he doesn't have any explanation for the drag problem. He doesn't have any explanation for any of the real problems with the particle model theory because he doesn't explain the fact that the particles are momentum carriers. He doesn't understand the push universe part, so it's pretty poor, frankly. It's a video cast, and they had on some good people. Well, you say so, okay? Frankly, you know. I mean, this is a pretty Glenn Borkert whack job, D. Hilster whack job. I'm sorry. These are guys who make claims all the time and they don't back it up with anything. They just say D. Hilster thinks he proved Einstein wrong. I mean, it's a stupid video about his, you know, his mother trolling, you know, science fairs. You know, it's a very interesting movie, but it has nothing to do with proving Einstein wrong. I'll save the link for later. And such. But I'm pretty sure I'm not going to be pleased. The whole D. Hilster crowd, that whole whatever it is, John Chappelle crowd, they're all a bunch of old creationists, you know, creation science people. They're really not in it for legitimate purposes, in the sense that they're dissidents for, you know, because they don't like the atheism of physics. You know. Yeah, well, I'm saying they're all out there. I mean, there was some guy who used to interview Bill Gates, you know, and they would engage in this whole rope theory bullshit and, you know, waste hours of people's time talking crap. I was arguing them with about time, and they say there is no time without memory. Well, don't you understand how, gee, on its face, that's just too silly. I mean, I don't even understand how anybody can fuck with time. I don't even know. I never had a problem understanding that the universe is like, okay, you could stop it at any moment. Stop it, freeze frame. And then you could start it and freeze frame. And then you could start it and freeze frame. And you start it and freeze frame. You start it freeze frame. I mean, that you could just understand that everything's doing the time thing. Everything's just doing the time thing. I mean, it's, what is there to make out of time? There's nothing to make out of it. Everything doesn't happen instantaneously, therefore there is time. Okay, yeah, done. That wasn't tough at all. Why do I need to make time into anything else? Why does it have to have wings? Why do I have to turn into a flying monkey? I mean, why can't time just be this simple? Yeah, it's on, it's off, on, off. I mean, you can just do it that whole incremental universe thing. You can say the whole universe was just pixels, and you're just turning the pixels on, turning the pixels off. You know, no big deal. Let's see, which I don't agree with, but they asked me to define time, which I think is pretty hard. Well, I'm just saying define time is simple. Just say nothing moves instantaneously from a point A to any point B in three-dimensional space. Therefore, there is time. Nothing is as fast as instantaneous. Okay. Do you have a definition of time? Yes. Uninstantaneousness. The universe suffers from uninstantaneousness, which means that it doesn't matter how fast the slowness is. The slowness isn't zero. Okay? So you know what I'm saying. It's not infinitely fast, and therefore it's slow. You could even say that. Because it's not infinitely fast, it's therefore slow, therefore there's time. That's a circular definition of time. Well, says you. I don't see anything circular about it at all. You're saying the instantaneous is a real thing. Okay, it's definable as instantaneous. This moved without using any time to get to a place. Frankly, there's things you can't break into a piece or change the meaning of the word. I mean, you can't define push without describing three dimensions and, having some rules about how you define the push. Let's see. It reminds me of a story where you broke your horse's clock when you were a kid, and you thought your house's clock, and you thought you broke time. Yes. I had a problem with inanimate, dumb pieces of wood being smarter than me. Okay, somehow the clock knew what time it was, and I was like, how the fuck does this stupid clock know, and I don't know? So I had to find out how the clock knew. Okay, and so I kept breaking the clock. I agree with you. They don't say motion is time, but they say time is a prerequisite of motion. I'm just saying, I don't see anything to be complicated here at all. I just can't see how you can make this complicated. There's a thing called dimensions of space, distance, and you're just saying it takes time to get from one point to another. I mean, fuck. What's so complicated? What you're saying is that time means nothing happens without time passing. Nothing happens if things are instantaneous. Oh, fuck. Yes, so yes, things have to go slow or nothing happens. Because everything happened already. If you don't have time, then everything already happened and there's nothing to talk about. I mean, obviously, this complex events can't happen if there's no time for them to happen. Because if everything happens at the same time, then the same thing has to be in different places at the same time, and the same thing can't be in different places at the same time. So there's no point in talking about there being a universe or there being anything complicated happening or there being any interaction, because if all the interactions happen in the same moment, they can't, because the same thing has to be in different places. Well, you can say instantaneous means without time passing. It means without there being any time delay, without there being any... It happened at the same moment of time. There's lots of ways to define it, so... But I don't see how the definition of instantaneous changes the simplicity of the argument. If you believe in dimensional space and you believe distance is a real thing, you're simply just saying that time is what it takes to move a distance, because things aren't instantaneously poofing to a location. They have to be pushed by some force, okay, that doesn't have instantaneous speed. I mean, this really becomes sort of a Mel Brooks movie, ludicrous speed. Yeah, there's no ludicrous speed, therefore there's no problem building clocks, because there's plenty of time happening. There's no fucking thing called a time. Time is an emergent function of slowness. Slowness creates a fart that we call time, but it's not a real thing. It isn't a meaningful thing. Time is just a after effect of the fact that things don't move instantaneous speeds. I don't believe time is a real thing. There's no such thing as time. There's no clock ticking anywhere. There's no measure of some rule. There's none of that. There's the rule that the stuff in the universe isn't moving instantaneous speed. It's a fact. The forces, the gravity, the magnetism, the electricity, the light, is moving this fixed speed. It has a fixed time it takes it from to get point A to point B, and that fixed time, that amount of slowness, is all there is. There is no time. There's just slowness. Slowness is the fundamental function of the universe. The fact that the little force bits are going so goddamn slow. Yes, the speed of light is, you could argue, it's almost infinitely slow. Right? I mean, it wouldn't matter whether we doubled the speed of light, or we tripled the speed of light, or we quadrupled the speed of light. The universe would work exactly the same way. It's the speed of the force that decides the function of everything. So everything is dependent on the speed of the force, the speed of the magnetism, the speed of the electricity, the speed of the gravity. And if you change that speed for all of the force bits, you wouldn't be able to tell the goddamn difference. I would be saying this twice as fast, but no one would know it's twice as fast. Time is a limiting feature. Whatever. Whatever. Slowness. And it doesn't limit anything. It wouldn't, like I said, if you sped it all up, it wouldn't make any fucking perceptual difference, because it's the complexity. The complexity, it takes a certain number of interactions. Make the interactions happen faster, and any measure of that speed will still be the same relative measure. You're still stuck with the same relative ruler you're going to measure it by. So, I mean, shrinking the universe to Horton Hears the Who size isn't going to make any difference about the function, as long as everything still has the same spatial connections. Can you define time without any reference to time? Yeah, I just said just make the reference to the fact that things don't move instantaneously. They don't poof from one place to another. Time, the fact that force bits have to set speed which isn't instantaneous. Yeah, well, I don't know if that's perfect, but it's what I'm saying. But yeah, I don't know if it's a perfect way to say it, but it's good enough for me. But frankly, like I said, I don't find this an interesting subject. I don't see how you people could possibly be confused. We use the word elephant to describe elephants. I mean, the word elephant doesn't mean anything. We could call it anything. It doesn't matter what the label is. Time is just a label for a function. The function is the universe doesn't do instantaneous. There. So because the universe doesn't do there's no evidence that it does anything called instantaneous, therefore there's this effect that we call time. But the effect is just the absence of instantaneous. It wouldn't change the fact that you could pick any certain thing to be your unit. So if the forces all move different speeds, you could still pick one. Okay. You could pick any relative speed and make every other comparison. We do it right now. We say 1 second. It doesn't matter whether it's, all the electrons move that speed, that far in 1 meter when pushed by 1,000 volts. It wouldn't matter what we used as a reference for the 1 second. We just find any one particular. We could say one electron, Joey the electron, okay, goes, 3/4 of the speed of light, 200 meters per second, 200 million meters per second. Well, anyway, so Joe electron goes that fast. We'll use Joe as the meter stick, so to speak. Doesn't matter. Wouldn't change anything. Obviously, the universe wouldn't work, but I just mean, it wouldn't change this definition of time. Time isn't dependent on the fact that the force bits blah blah blah. Time is dependent on the fact that nothing breaks the rule. No instantaneous rule. It's an uninstantaneous universe. Therefore, it has an exhaust, an effect that looks like time. Yeah, well, that's pretty much what it is. It's like saying an elephant is an animal, looks like an elephant. Well, I'm just saying it. You don't, what are you going to do? There's no hippopotamus to compare this to. There's no duplicate function that's just like time. So we can't make analogies to some other function that's just like time. So all you can do is make an axiomatic statement and say, well, the absence of instantaneousness is elephant. There, I have a word for it. So what? Again, why is this fucking thing mean anything to you fuckers except that you want to go have sex with unicorns? I mean, what besides your perverse desire to have sex with a unicorn are you making up this story that somehow time is significant in some way? That this is a really interesting subject. Oh my God, I got to figure out what time is. Blah, 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 blah. Why? What kind of perverse story narrative is running in your head that you think this is fucking goddamn fuckable? What about this fucking phenomenon of time is it all worthy of pumping? God, I just can't see why you are fucking this asshole. Time is just an asshole. It isn't worth the trouble. Alright, if you listen to Sean Carroll enough, I'm sure you've heard him say that time passes at 1 second per second for everyone. We're all made of the same force. The force functions by these explicit hard rules. So obviously there's no special Coke machine that has speedier electrons. I get he is making a relativity argument, but does 1 second per second make any sense? Well, whatever, the per second thing doesn't make any sense, of course. So obviously he could just say per second. And we're done. The redundant added point that, hey, it could happen for 10 seconds. Hey, it could happen for 1,000,000 seconds. Yeah, it happens over and over again if you're free falling. But, whatever. And obviously, in the universe, it happens all the time because we're always in the universe. So time is always affecting us in the sense that events will take place at a certain, course. They will happen incrementally over a period that we could call time. You could say that time is activity radiation. I wouldn't say it. Obviously, it has to do with the absence of an instantaneous motion in the universe, okay? That things can't just B at point A and then B at point B. And the fact that they can't do that, that they have to be pushed, it's a push universe. So a better statement would be you can say that time is the consequence of things having to be pushed to different locations, and pushing takes time. I'm trying to strengthen my understanding of time because a lot of people have different views of it. Well, I'm just saying whatever, if somebody has a view of time, I'm saying to you they're unicorn fuckers. Because, frankly, I can't see how anybody can waste any time at all on the subject. I just can't see what the fucking problem is. You know how fast the stuff moves in the universe. You know some is insanely fast, the speed of light. The speed of my thoughts is insanely slow by comparison. It takes trillions and trillions of events to take place for my brain to make one fucking sentence. So why am I confused at all? I understand the complex interactions. A bunch of stuff has to move a whole bunch of distance inside my brain. A bunch of electricity has to go miles and miles and miles and miles and miles. You know, light years almost of distance. And then I poof out crap. Okay? And that crap took distance. A lot of electricity had to travel a lot of distance for my thoughts to be put into words. Fact. And so all of that distance takes time because the stuff moving the distance doesn't go infinitely fast. Okay, anyway. God damn it. My definition doesn't interfere in any way with your theories, right? I don't care. How could it possibly interfere? My theory is time is unicorn fucking. That's my theory. My theory is if you are worried about what the fuck time is, you're an idiot. Okay, that's my theory. So I guess in a way, your definition, the very fact that you would waste time trying to define it, is pretty much just saying you can't understand. It's a fucking elephant, jackass. Just a word, elephant. Yeah, it's a little weird, but it's just a fucking word. It's just a label for when you have a trunk and you have a tail and an ass and floppy ears and blah, blah, blah. So just shut the fuck up. It's an elephant. Move on. Doesn't light itself have a speed? I don't even know why the fuck you would even say something so goddamn fucking stupid. Doesn't light itself to have a speed need time first to travel? What the fuck are you talking about? So again, you want to turn it into a thing. You want to make time into a physical fucking thing. What the fuck are you talking about? There's empty space. There's a place in the empty space, a location called X. You're going to go to X and you can't go there instantaneously. Why the fuck does light have to have anything? It doesn't have to have anything. It doesn't have to wait for time to open the door. Oh, fuck. Time isn't a substance. It's not a thing. It's not a function even. It's the absence of a function. I mean, I shouldn't say it's the absence of a function because, yes, the function is slowness. I just said it. If slowness didn't exist, then there wouldn't be any time, and then we wouldn't have a conversation about it. But the fact is the universe contains slowness. There. That's the real thing. Slowness is the real function. There's slowness in the universe. The end. We're done with the conversation. Time is not a subject anymore. God, the phantasmagorical is all strong with you people. You are just such, I'm sitting here trying to train Jedis, and all you people are showing up in your ballet dresses. Fuck. Alright, it's your channel, so I'll stop talking about it. Yeah, well, I appreciate it. I mean, I have my point that I just can't. Why do I want to talk about some? This is just such a niche thing for you people. This is your little nichey subject, you know. You want to make a subject out of something that's not a subject. Okay, well, go ahead and do that. But I can't find the subject. I mean, of all the physics concepts I've thought about in the last 10 years, time wasn't anywhere even close to one of them. I thought more about elephants, just accidentally thought about elephants more than I thought about time as being relevant to physics somehow. I mean, the existence of time. It's just not a... It's just... You want to think about the existence of an electron? Okay, yeah, all right. You can play that. You can play that for a minute and a half, maybe, and think about, wow, where do the force bits come from? And you think about that for a minute and a half. But I couldn't give 4 seconds to thinking about time. I mean, it's an incremental universe. I mean, you can break it into pieces. You can just break it into event, 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 event. I can make the pieces really, really small. I can make the pieces really, really big. But they're just events taking place, and especially in the tiny universe. So if you understand the only universe is the small universe, then you understand that, yeah, it's just doing this, you know... things pushing, banging into things thing. It's just bumping particles, and none of the particles are going instantaneous speed. A bunch of particles aren't going instantaneous. There could be some that are going instantaneous, and we have no idea of their existence, but it's not a very likely proposition. But the fact is, there's a ton of shit not going instantaneous speed. There, we're done with the subject. Slide that off the table and talk about something real. Alright, so it looks like you're out of fuel. Oh, it's just so annoying. People can't stay on the subject. I mean, physics has made a critical, gigantic error in creating 1/2 mv squared living force wooey physics. Made a gigantic mistake, and this is what you want to do. This is what you want to talk about. If I slowed the universe down, would time be spelled T-T-I-I-M-M-E-E? If everyone in the universe suddenly stopped, if everything, would it make sense to say that time was still passing? It doesn't care. Who cares? Again, it's not a thing. There is no thing. Okay? There's no time thing. It's an emergent consequence. So obviously, if you were an observer observing a frozen universe, you obviously wouldn't be frozen. Oh, God, this planet of fucking goddamn imbeciles everywhere. Alright, endeavor to persevere, Gary. Endeavor to persevere. God. The depth of the fucking goddamn intellectual sewage. Alright, so I'm gonna call it quits. Go fucking dig in the dirt or something. Find something rational to do. and communicate with humans. Alright, so once again, you have disappointed me, but I'm used to it, so it doesn't really matter. So, till the next time and such, and so forth and whatnot, when I again will attempt futility. Yeah, that's pretty much it's an attempt to. It's just futile. Why do I? Because I don't have a choice. That's why. There's only one war to fight, and this is the war, and there's just nothing else to do. You have to fight the fucking goddamn giant pus monster that's going to, burn your house down.